Hi everyone, the channel Easy Lecture welcomes you. In our previous video, we discussed the theory part related to classification of system. In this video, we are going to discuss the problems related to the classification of system. To discuss that, I have taken two problems which were asked in Anna University semester examination under the subject code EC8352 Signals and System April May. So one question is from April May 2019 question paper examination and another question is from November December 2018 examination. So before entering into the video, subscribe my channel Easy Lecture. Now let us go for further discussion. The first question here is a continuous time system has input output relationship given by y of t equal to t into x of t minus 1. Determine whether the system is linear, time invariant, stable, memoryless and causal. So we have to find whether the given system is linear or non-linear, time variant or time invariant, stable or unstable system, or a system with a memory or memoryless system, and causal or non-causal. So these are the things that we have to find. Okay. So what are the things that we can find on seeing this equation of the system? Okay. So here the current output depends on the past input. So there should be some memory to hold, to save, to hold the past values. Okay, so memory is required. So definitely this is not a memoryless system, but it is a system with memory. Okay, so this system, this condition, this thing we can find instantaneously on looking the system equation. Then the current output of the system is not depending upon the future inputs, instead it depends upon the past inputs. Okay, if a system has output depending upon the past input and present input, then we can say that the system is a causal system. If it depends on future input, then we can say that it is a non-causal system. Here the condition is our current output depends on past inputs, so this is a causal system. Alright, so this thing we can find instantaneously. Okay, and we can also find whether the system is time variant or time invariant. So in the previous video I mentioned, if a system has, okay, if the system output of the system depends on the input and the input is a time scaling factor, then definitely that system is going to be a time variant system. If time shifting is there, if in the input instead of time scaling, time shifting is there, then definitely the system is going to be a time invariant system. Time shifting means time invariant. Okay, so time scaling means time variant. But here we have time shifting, there is no problem in that, but look at the scaling of amplitude. It is scaled by a factor which is dependent on time. Okay, so it is not scaled by any number, any constant value. Instead it is scaled by a time factor, by time. Since time scaling is occurring in the form of amplitude scaling, we cannot say that that system is time invariant system, but instead it is going to be time variant system. Okay, so this is going to be time variant system for sure. Okay, so this thing also we can find immediately on looking at the system equation. Then now stable, looking at the stability as t tends to infinity. So stability means bounded input should produce a bounded output. Okay, so that means the amplitude of the signal, okay, the amplitude of the signals, both input signal and output signal, should be finite as t, as the time t tends to infinity. So this is the thing, this is what we mean by bounded input should produce bounded output for the system to be stable. Okay, but here look, y of t is equal to t into x of t minus 1. As t tends to infinity, look at the amplitude of y of t. As t tends to infinity, y of infinity becomes infinity into x of t minus 1. Infinity into anything is infinity. So we do not have bounded amplitude as t tends to infinity. We have unbounded amplitude. So this system is not stable. It is an unstable system. So this is also not obeying. Okay, so all these things we can find immediately on looking at the system equation. Okay, now let us work it out. So here as t tends to infinity, y of infinity equal to infinity, so it is an unstable system. Okay. Now, y of t equal to t into x of t minus 1, it means we need some memory to hold the past values. So, it is a system with memory, it is not a memoryless system. Okay. Then the output, the current output depends on past input. For this case, it is a causal system. Okay. It does not depend on previous inputs. Then when the input is time delayed, we will be having the equation y of t comma t naught equal to, okay, input is time delayed by a value of t naught. Here we have t into x of t minus t naught minus 1. Okay. And for time delayed output, we have y of t minus t naught equal to t minus t naught into x of t minus t naught minus 1. So, these two equations are different, this equation and this equation are different. Since they are different, then the system is a time variant system. Okay. So, as I mentioned, if time scaling is there, definitely the system is going to be time variant system. Here time scaling is there, so this system is time variant system. So, all these details we can find immediately on looking at the system equation instantaneously. Now, let us check whether the system is linear or not, linearity of the system, that is what we are going to find now. Y of t equal to t into x of t minus 1. Now, let us give the input as x1 of t. Okay. So, to find linearity, we must ensure that the system is obeying superposition principle, that is, it is obeying both homogeneity and additivity principle. So, that is what we are going to prove here now. Okay. So, instead of x of t as input, let us assume that we are giving input as x1 of t. If we give x1 of t as input to the system, then the output will be getting y1 of t, which is nothing but t into x1 of t minus 1. That is what we have got here. Okay, t into x1 of t minus 1. So, to the same system, we are giving a weighted input, and the input is weighted by a factor of a into x1 of t is given to the system. We are getting the output as a into y1 of t, which means a into t into x1 of t minus 1. Now, we are giving next input weighted by another factor to the same system. Okay, we are giving b into x2 of t to the same system. We will be getting b into y2 of t as the output, which is nothing but b into t into x2 of t minus 1, because the system is same, we are not changed the system. Okay. Now, here we are making an assumption, let x3 of t equal to a into x1 of t plus b into x2 of t. The reason is we have to prove additivity and homogeneity. Okay. So, for this reason we are making this assumption. Now, we are giving this signal as input to the same system. So, x3 of t is given as the input to the same system. We will be getting the output as y3 of t, which is nothing but t into x3 of t minus 1. Now, let us replace x3 of t minus 1 by this equation and we shall solve it. When we solve, we will be getting y3 of t equal to a into t into x1 of t minus 1 plus b into t into x2 of t minus 1, which means a into y1 of t plus b into y2 of t. Okay. So, weighted added input is producing weighted added output. Okay. So, this is the conclusion that we are making. So, homogeneity principle is obeyed, superposition principle is additivity principle is obeyed. For this reason, superposition principle is also obeyed, and finally we can conclude that the system is a linear system. Okay. So, this is related to the first problem. Now, let us move on to the next problem. The question is, check whether the given system is linear, non-linear, time variant, time invariant, causal and non-causal, and the system equation is y of n equal to x of n minus x of n minus 1. So, what are the things we can find immediately on looking at the system equation? So, x of n minus x of n minus 1, the current output is depending upon the current input x of n and the previous inputs, the past inputs x of n minus 1. So, definitely it is going to be a causal system. So, this is over. Okay. And here there is no time scaling is involved. For this reason, it is going to be time invariant system, only time shifting is involved. Okay. So, we can conclude that this is not going to be a time variant system, it is going to be a time invariant system. So, this is also a time invariant system. Okay. Then linearity and non-linearity, we have to check homogeneity, so homogeneity principle and also additivity principle, that means superposition principle we are going to check. Okay. So, x1 of n when we give that as one as the input, we will be getting the output as y1 of n equal to x1 of n minus x1 of n minus 1. When we weight the input by a factor a, we will be having a into x1 of n is given as the input to the same system. We will be getting the output as a into x1 of n minus a into x1 of n minus 1. If we give weighted x2 of n by a factor b as input to the system, same system will be getting the output as b into x2 of n minus b into x2 of n minus 1. Okay, again we are making the assumption to prove the homogeneity and additivity principle. The assumption is x3 of n equal to a into x1 of n plus b into x2 of n. Weighted added inputs to inputs. Okay, so weighted added input is weighted added inputs are given to the same system. That means x3 of n is given to the same system, will be getting the output as y3 of n, which is equal to x3 of n minus x3 of n minus 1. Okay, now we shall solve it. When we solve it, we will be getting a into x1 of n minus a into x1 of n minus 1, which is nothing but when we take a common outside, we will be getting a into y1 of n. Okay, similarly b into x2 of n minus b into x2 of n minus 1, when we take b common outside, we will be getting b into y2 of n. Okay, so for this reason y3 of n is equal to a into y1 of n plus b into y2 of n. Okay, so here homogeneity principle is obeyed, additive principle is obeyed, so superposition principle is obeyed. For these reasons the system becomes a linear system. The system is linear. Okay, we know y of n equal to x of n, so it is a causal system. Now to check the variance of the system, time variance of the system, when we give time delayed input y of n comma n naught, time delayed by a factor of n naught, y of n comma n naught equal to x of n minus n naught minus x of n minus n naught minus 1. Time delayed output produces y of n minus n naught equal to x of n minus n naught minus x of n minus n naught minus 1. So comparing these two equations, they are same. Since they are same, we can conclude that the system is a time invariant system. In the previous question, those two equations were not same. Okay, so time delayed input is not producing the same time delayed output, the same kind of time delay in the output. For this reason, in the previous question, we concluded that it was a time variant system, whereas in this question the time delayed input is producing the same kind of time delay in the output. So this system has become time invariant system. Okay, so I hope you have understood how to solve the problems related to classification of system, how to identify whether a system belongs to a causal or non-causal, or memory or memoryless, stable or unstable. So all those things, so certain factors can be analyzed, can be found out immediately on looking at the system equation. I hope you have understood that. You can give your valuable comments on the comment box and share this video with your friends. Don't forget to subscribe my channel Easy Lecture. Meet you again in another video. Until then, bye. Thank you.